Cold open, the biggest security story this week is not one single breach. It is a pattern. Attackers are using ordinary business workflows, stolen credentials, and fast-moving automation. At the same time, defenders are adding AI memory, AI agents, secret scanning, and post-quantum planning to systems that already carry real risk. The question for today is simple: when AI and automation enter security operations, do they reduce risk, or do they create a bigger blast radius? Here is the central thesis. Security teams are entering an era where identity, AI agents, and developer tooling are all part of the same attack surface. The winning organizations will not be the ones that adopt the most automation first. They will be the ones that control permissions, verify behavior, reduce alert noise, and keep sensitive actions auditable. First, Microsoft reported a PhotoZip campaign targeting hospitality organizations and delivering a Node.js implant for persistent access. The lore matters. Hospitality teams handle booking requests, event photos, vendor messages, customer files, and last-minute operational changes. A photo archive can feel normal in that environment. That is why social engineering continues to work. The attacker does not need the weirdest exploit if the message fits the job. At a safe level, the lesson is not about copying the malware. It is about understanding the intrusion path. A convincing file reaches an employee. The employee opens it because the business context feels plausible. A foothold is created. From there, attackers look for credentials, persistence, internal visibility, and ways to move deeper. For defenders, that means email filtering alone is not enough. You need attachment detonation, endpoint visibility, application control, identity alerts, and a culture where reporting a suspicious file is rewarded instead of punished. Second, Microsoft analyzed StealthSea and Amadeus, focusing on infostealers and the cybercrime services that deliver them. Infostealers are especially dangerous because they turn a personal compromise into a corporate incident. A stolen browser session, password vault export, cookie, or token can bypass the mental model many people have of security. The attacker may not need to guess a password if a session artifact already proves identity to a service. This is where the line between consumer security and enterprise security disappears. Employees use browsers all day. They sync profiles. They move between work tools, personal accounts, SaaS dashboards, and developer portals. If a device is compromised, the impact may include cloud consoles, source repositories, help desks, payroll systems, and customer data. The defensive answer is layered, hardware-backed multi-factor authentication where possible, conditional access, session revocation, device compliance, least privilege admin roles, and fast rotation when secrets are suspected to be exposed. Now connect that to AI. Microsoft published guidance on guarding AI memory. AI memory is attractive because it makes assistants feel more useful. A system can remember preferences, project context, writing style, or recurring tasks. But memory also raises security questions. What is allowed to be remembered? Who can update it? Can an untrusted email or web page manipulate it? Can sensitive data be retained longer than policy allows? Can a user inspect and delete it? The key risk is not that memory exists. The risk is unmanaged memory. If an assistant remembers the wrong thing, or stores sensitive context without clear controls, it can influence future decisions invisibly. For businesses, AI memory needs the same governance mindset as databases and logs: classification, retention, access control, auditability, and user transparency. For developers, every memory write should be treated as a security-relevant event, not just a product convenience. The payoff question we asked at the start was whether automation reduces risk or increases blast radius. Here is the midpoint answer. Automation reduces risk only when its permissions are narrower than the damage it could cause. If an AI assistant can read sensitive data, update tickets, summarize files, or call tools, then its authority must be explicit. The system should know when it is quoting a trusted document, when it is reading untrusted content, and when a human must approve the next step. That leads to Microsoft's AutoJack research, which described a web page to host remote code execution pattern involving AI agent environments under certain conditions. We are not going into operational details. The defensive lesson is enough: AI agents create bridges. They may connect web pages, browsers, local files, command tools, cloud APIs, and internal systems. Any bridge between untrusted content and powerful tools needs guardrails. Practical controls include sandboxing the agent runtime, separating browsing from execution, blocking automatic tool use after untrusted input, requiring confirmation for file and system changes, logging agent actions, and designing rollback paths. In other words, do not treat an agent like a smarter chatbot. Treat it like a junior operator with access to tools, and give it only the minimum authority needed for the task. Cloudflare's recent writing on defending against frontier cyber models points in the same direction. If AI increases attacker speed, defenders need architecture that absorbs speed, rate limits, behavioral detection, real-time rules, segmentation, and response automation that can act before a human finishes reading an alert. But automation must be carefully scoped. A bad detection that automatically blocks customers, deletes data, or disables business-critical systems can become its own incident. Cloudflare also highlighted post-quantum migration after the White House executive order. This topic can feel distant, but the operational work is not distant at all. Organizations need to know where cryptography is used: public websites, VPNs, device certificates, code signing, backups, internal service mesh, embedded systems, and vendor integrations. Post-quantum readiness starts with inventory and testing long before a final migration deadline. The final source today is GitHub's discussion of reducing false positives in secret scanning at scale. This may sound less dramatic than malware or AI agents, but it is one of the most practical developer security stories. Secret scanning works only if developers trust it. If alerts are noisy, people stop responding. If alerts are precise, teams rotate credentials faster and prevent exposed tokens from becoming supply chain compromise. For engineering leaders, the lesson is bigger than one feature. Security tools compete for attention. Every low-quality alert spends human trust. Every accurate alert builds it. If you want developers to act, alerts need context: what secret was found, where it was found, whether it is live, what system it affects, how to rotate it, and who owns the fix. So what should businesses and builders do next? First, assume social engineering will target ordinary workflows. Train around realistic business lures, not cartoonish phishing examples. Second, reduce the value of stolen sessions with phishing-resistant MFA, conditional access, short-lived tokens, and fast revocation. Third, treat AI memory and AI agents as security components with permissions, logging, deletion, and human approval. Fourth, prepare for AI speed attacks with layered detection and scoped automation. Fifth, start post-quantum inventory now. And sixth, make developer security alerts trustworthy enough that people act. Before we move to the checklist, there is one more operational point: ownership. AI and security projects often fail at the boundary between teams. The platform team may own identity. The security team may own detection. The data team may own model access. The application team may own the workflow where the agent actually acts. If nobody owns the full chain, nobody notices when a harmless feature becomes a powerful automation path. A practical governance model assigns an owner for each AI workflow, an owner for each tool permission, and an owner for incident response when the workflow behaves unexpectedly. That ownership should include tabletop exercises. Ask what happens if an agent summarizes a malicious email as trusted instruction. Ask what happens if a stolen developer token is used minutes after it appears in a repository. Ask what happens if a post-quantum migration breaks an old device fleet. Ask what happens if a security automation blocks a real customer during a false positive. These are not fear scenarios, they are design tests. The goal is to find the failure mode while the system is still small enough to change. For individual users, the advice is also practical. Keep work and personal browser profiles separate. Do not store every credential in a browser that syncs everywhere. Use phishing-resistant MFA where it is offered. Review connected apps and revoke old sessions. Be careful when an AI tool asks for broad access to email, files, calendars, or code. The more helpful the assistant becomes, the more important it is to know exactly what it can touch. The conclusion is this: AI is not separate from cybersecurity anymore. It is entering the inbox, the browser, the help desk, the code repository, the cloud console, and the security operations center. That can make defenders faster. It can also give mistakes and attackers a larger surface. The rule for the next wave is simple: automate carefully, verify independently, and never give software more authority than you can monitor, explain, and revoke.